Welcome everyone to our next Master Lecture in the Go Fly Master Lecture series. My pleasure to introduce Gwen Leiter, CEO and founder of Go Fly.
Thank you, Nidhi, and welcome everyone to today's Master Lecture. As you all know, Go Fly's grand sponsor is Boeing. And in addition, we are joined with corporate sponsor Pratt & Whitney and over 20 different aerospace organizations join us, as well as our in-kind sponsors. So today, we are so pleased to be able to welcome Johnny Du to give today's master lecture. Johnny Du is president of the International Vehicle Research, Inc., focusing on innovative manned and unmanned flight vehicle technology and product development, while also supporting global rescue and disaster relief initiatives. In addition, he leads the NASA-coordinated Transformative Vertical Flight Public Services Working Group, teaming with 50 industry and institution expert and executive members to develop a roadmap for search and rescue, disaster relief, police and firefighting, medical transport, and military eVTOL applications. Johnny has over 30 years of experience in managing and developing aviation products, from high-performance piston aircraft, personal and business jets, to unmanned aerial vehicles. Johnny Du holds a bachelor's degree in mechanical engineering and a master's degree in aerospace engineering. He is also the co-author of the book entitled Wigcraft and Ecranoplan Ground Effect Craft Technologies. It is our great pleasure today to welcome Johnny Du, and thank you so much, everyone, for joining us.
You're quite welcome. Thank you. Be delighted to be here. And you guys can see the slide, okay?
It looks like we're in presentation mode, Johnny. So if you'd like to switch it to full screen.
Okay. That is. On my side, it is a full screen. Did I try the... All right, let me try another file. And put that on full screen. They're not working?
Almost there. Let's try full screen on this slide, and it should work. There we go.
All right. Okay.
Yeah.
All right, guys. And ladies, welcome. Today we're going to talk about the eVTOL for public services and design application. Appreciate the invitation, and also, I'm going to go through the slides a little bit quick. In case you have any questions, feel free to ask, and also feel free to contact me if you want certain specific details. And quickly go through an outline. I'm going to talk about a little bit about my vehicle background. Thanks for the introduction already. And we're going to talk about the flight vehicle design approach, just a general approach. What are we going to do with the Go Fly program? I'm sure there's future program that probably follow, but you're already putting a lot of effort that can be put to good use. And I'm going to quickly introduce the NASA Transformative Vertical Flight Working Group for Public Services and its application. Then we get into this public service vehicle specification, specific functions and requirements, and we can talk briefly about a distributed on-demand eVTOL mobility system concept. And finally, we just briefly say, what do we do moving forward? I'm a visual person, so here's a few pictures of the airplane I worked on or responsible for, and the center lower part is a Mooney 301. It's a kind of pretty advanced at this time. Full plan, 90% follow flap, laminar flow airflow, turbocharged 250 horsepower engine, pressurized cabin, and all that. It's a very amazing airplane. And in the upper middle is a interesting aircraft that's Mach 0.84 cruise speed up to 49,000 feet, 2,500 nautical mile cruise range with reserve. That's a challenge, and it's a fun one, I tell you. On the left-hand side, some of the special mission airplanes, as well as a airplane that I helped certify to with CAC. The first two airplanes go to Hainan Airlines. And of course, the lower left corner is a picture of a diesel engine powered Piper. And that can be a pretty interesting future development. On the right-hand side, some of the general aviation airplane, including the second down, it's a Nemesis. It's a racer airplane. And of course, you can see in the middle is a hovercraft and a few pictures on the lower side. So there's some hovercraft work. Those are some of the hovercraft that you developed. On the left-hand side is just the book that Glenn already talked about. On the right-hand side, again, engine development, and the middle picture on the right is a diesel engine, direct drive, pretty advanced diesel Jet A powered engine. Took that airplane, that engine to finish the development to certification, and of course up and lower is additional diesel powered general aviation airplane. On the top is a UAV. It's under 30 kilogram max takeoff weight, and ducted vertical takeoff project proposal. And one of the most challenging project I have was a Diamond D-Jet that start from scratch, put the team together, build up the operating system, design, establish the surveys, develop the airplane, design from inside out, build the airplane, fly it. We got the prototype, proof of concept prototype, flying within 13 months. And then 17 months later, we got a production configured aircraft, see in the upper left flying. That's a pretty aggressive schedule, but that is what I call the true teamwork. Got a great team there. So enough about me, but I thought I'd give you a little background so that you guys know where I'm coming from, and we can communicate better forward. Now, basically, we can design airplane in a couple of three different major approaches. And many of them, tell the truth, being successful is you build it and they will come, especially with a totally new field, things that people have not tried before. That quite often actually was the approach that's taken. Now, of course, with a little bit more systematic approach, you could be having a targeted mission and market, knowing what you're looking for. That is a good way to ensure commercial success moving forward. Of course, there's other programs that the user or the end customer has a specific spec and requirements. Actually, for example, the Go Fly competition. There's a given very specific guidelines and criteria, and you do whatever innovative development you can come up with to achieve and fit within that criteria. Of course, we all have seen a lot of different 150 some different design, in addition to all the Go Fly projects that's ongoing right now. But they all have different features. It's very, very different. This is kind of breaking the tradition from the so-called conventional aircraft design, the fixed wing or the helicopter. Right now, everyone has different ideas for what will work best. And I'm sure there's many different ways to address the challenges and opportunities there. And of course, Well, seeing the Go Fly competition, I'm so excited about seeing this effort because I think this is the best way to get the best idea out there. Not everyone is going to work the same way, but I think this is by far the most creative activity I've seen for a long time. Now, if we were to look at a more commercial aspect of the business, then we need to kind of figure out what is the target market and what is the application of the platform. Winning the competition is definitely the first step, but moving forward, they may have some commercial business thinking that in order to enable us to take the next step. And we need to be able to assess the market size, and which also not only how many you can sell, but also dictate what kind of production volume you may want to plan for. Now, this is all product basically have some price sensitivity, but not to the same level. Some certain missions, certain applications are very price sensitive, especially personal ownerships and so on, or commercial, the air taxi and so on. They're very, very price sensitive and operating cost sensitive. But also, in addition, to consider all those time to market. How fast do you have to get there? For some startup and newbies, we may have to get the foot in the door quickly and start showing what you can do and so on. But certain other companies may take a different approach. They want to take a little bit more time to get a system more mature before introducing to the public. And of course, the timing approach may be driven by financial expense, funding sequence, and so on. Talk about the mission. Basically, in most cases, we design flight vehicle, we have certain mission profile because that drives the design. Mission profile, one vehicle may have the ability to meet more than one mission successfully. But if you try to have a vehicle that can fly vertically for 2 hours, and then the same time, the same vehicle, you want to be able to cruise for 1,000 nautical mile range, that may be a very, very hard to do kind of conflict of mission because you have to compromise too much on one and to the other. So quite often we design one airplane that can have 2 or 3 missions, but in the similar spectrum. There's many ways to develop a product. One is a scale prototype. It's too big and too expensive to start right off the bat in designing a big airplane and build the airplane. Sometimes a scale prototype makes a lot of sense. And it is also important to develop subsystem development, bench test, integration on onboards and so on. That a lot of times can reduce your risk in the once you try to fly the real vehicle. And do we do a technology demonstrator with a concept aircraft? That is a matter of choice, depending on the approach of the program. And sometimes you need a quick design, build, test approach, especially with very new configuration, new technology that quickly put something together, learn about it safely. I want to emphasize that. Maybe a good approach. And of course, we know nowadays we all leverage the computational tools, the CFD, the FEM structure, topology optimization, simulation. Not to say that by the time I get to the DJ program, in the old days, we do a lot of wind tunnel tests. We will configure the airplane, we do different configurations, spend a lot of time, multiple tunnel entry to progressively narrow down the configuration. By the time we get to the DJ program, we are heavily dependent on the CFDs and structural analysis and so on. By the time we get in the tunnel, we virtually have no change. We're validating the analysis. So now the eVTOL is a little bit different story because even though the computational tools are catching up, but the flow field around the vehicle is very, very complex. and you have multiple different flight phases and flight conditions, that could pose a challenge, and therefore some of the scale tests and other testing may be good complementary approach to the basic analytical approach. Of course, structure testing is always good. If you're going to put somebody in the airplane at some point, go through a minimum approved test. Doesn't have to be so overly sophisticated. For example, on the DJ, on the proof test, and our certification test for proof test, we basically flip the wing upside down and put a whole bunch of sandbags. Get a whole bunch of office team, get some community exercise out of it, loading a whole bunch of sandbags to load it. Of course, we had to put some boundaries holders too, so that the sandbag won't fall off the wing, in order to load enough sandbags to generate the loads that simulate the flight load. But some kind of loading testing may be a good idea before we actually go fly. Of course, the flight test program, perhaps today we can always do a lot of testing unmanned, without people around and safely, only after we have sufficient confidence before we put the person on board the airplane. It's a great way. Of course, we have to be aware of a working software doesn't mean it's certifiable. That is a challenge, especially for eVTOL. So let's look into that further. Now, of course, a lot of eVTOL, the reason we were able to be so moving so fast with so many different design configurations, we were able to leverage a lot of new technology coming on board. Of course, we have to further development in order to fit those technology into the vehicle we're designing. Of course, power lift, transition, aero control, the lift propulsion system, motor control, and the rotor duct efficiency. Do you want a duct? Do you not have a duct? Lift cruise balancing system, balance system. How do you balance between those two requirements? Energy storage, big challenge. The battery or other form of fuel cells and other energy source. It's challenging at this point, especially, that's why today we're still more limited by the flight time. If it's all battery, how fast can you charge it? We're working on air taxi. Charging time is critically important. And if you look at the picture on the middle lower point, that's the size of one of the proposed connector for the air taxi eVTOL. That's not your granddaddy's electric car charging plug. So how do we establish a standard, industry standards, so other vehicles, different vehicles can be, we don't have to fly to somewhere and unable to charge it. Try to avoid that. Of course, the structure manufacturing methodology, how do we design a medium low volume vehicle? It's low volume for automotive. It could be very high volume for airplane. How do we strike the balance? 3D printing, rapid prototyping, all very good ways to enable us to develop and certify airplane. But what's the cert based on the specific material used on that printing? Something to look into. And of course, navigation, sense of void, always challenge. Today, we have a lot of technology that we can leverage, especially from the UAV industry and automotive industry. That's going big time. It's making huge progress. But if we incorporate AI, how do we certify in flight? It's a complementary system. It's a basic safety system. And of course, unmanned traffic management system. You have to design the vehicle so that it can fit into that system or work with the system. But that's also enabled. Without it, we can't really safely fly around. Of course, 4G, 5G network, maybe 5G is all the buzzword nowadays, but 4G may still be quite needed, especially in a outskirts, rural areas and so on, that 4G has a range, unless 5G team can extend that range and the data speed. Some of the key design considerations: configuration, layout, payload range, endurance, trade-off between hover and cruise, weight and balance, important. Noise, okay. Yeah, it depends on where you use it. If you use it in the farmland, maybe people less care about that. But in most cases, community noise is a big issue. Motor propeller fan is source. Battery management system, charging, fueling. If you have a range extender, how do you do that? System reliability and redundancy. Redundancy doesn't mean higher reliability. You've got to be careful sometimes how we design it. Technical software, specification, material structure concept, autonomous, navigation, airspace operations, cost, always critical parameter, acquisition and ownership, lifecycle cost, material manufacturing methods, and design for producibility. That's part of the approach to keep the cost down. Service and maintenance, that's critical. If you ever go into the commercial operation or government service and so on, service and maintainability is huge. And technology is a great thing that's enabled, but also pose some challenges on the certification, because are they ready? How far have we gone? The new technology may be lacking existing survey, so you may be developing the data from scratch, with past time and cost. And supplier support, counting on that, is the system can be TSO, and then incorporate that integrate it into the aircraft system. And what's the surveys? And what's the meaning of compliance? Make sure that you leverage a lot of good work on the eVTOL related technology and subsystem standards and so on from SAE and ASTM. FAA, ELSA, Transport Canada, CAC, what's the rules? Different agencies has a little bit different approach, especially on eVTOL, because it's new. And I'm sure over time it will come back and harmonize again, but at the early stage, we have a little bit different approach. We need to be aware of that. And not just the vehicle type certification, but also operating cert approval. How about the local law and rules? What depends on what you use it for. So my point here is that certification will drive the design concept and details. One of the things I like to point out is the weight and cost management. And if you look at the chart on the left, that's a typical aircraft. Lower line is the actual database weight, and the upper line is predicted, estimated, and potential weight. It rarely have I ever seen an aircraft program that the aircraft doesn't come in underweight. Most of the time, you come in overweight. And over time, as you design, you more mature, and you take into certification requirements and maintenance, certification, and maintenance operation into account, quite often the weight goes up, and you have to anticipate that and manage accordingly. Of course, the right-hand chart purposely blur it out so they don't see the data, but it's a way to track, different different build level, different build stations, how much weight is it in-house build, supplier weight, and so on. What is all the cost to go with that? Cost is added up. That simple, well, actually, that's a lot of data, on the subcaps and so on. But that is the kind of effort would be helpful to start with, to have a simpler one, but to have a visibility on both the weight and the cost to be successful program. And design for producibility, one of the things I kind of brag about is, of course, you have to figure out what's your design concept, what you want the airplane to do, how you want to build it, where are you going to build it. If you want to have multiple assembly sites, you may want to have leverage more of the 3D printing. You can build more of the airplane and so on, locally and so on. But there's many manufacturing technology that's advancing fairly rapidly. If you look at the left-hand side, that's one of the US wing that was printing, the right-hand corner, we were able to print at pretty low cost, a 12 by 12 by 24 inches volume, build volume. That becomes very useful, especially in prototyping stage. And you can use 3D printing to make tooling. It's sometimes the tooling is a very long lead time. Using 3D printing to produce 3D tooling is a good way to accelerate the program. First, you can machine it. The high-speed machining is getting so good, and the cost is coming down more and more so. And do you think that we can, we may have a challenge in printing man-sized aircraft? Well, think again. The center picture is the Ulrich Research Lab. They have been printing full-scale cars several years back. Huge, from high-tech metal printing, composite, all the way to large-scale printing. It's impressive. I think the future will see more of this kind of capability and technology to enable us to move forward faster and better. And we can design things that we normally wouldn't be able to. One of the best things about 3D printing, the more you optimize it, the lower the cost. Reason being, quite often is go by the volume of the material you actually use, because it's additive. So that if traditionally we had to pocket out, like the machine out, so we had to pocket out every time we tried to remove material, it costs extra money. And but on the 3D printing, the less material you need or use, the lower the cost and less the time. So GoFly program, many innovative designs, and has been targeted for a set of requirements for the competition price. And the advantage, we have most of the team start to prove out the vehicle concept development, technology validation, integration, small envelope. I like that. I'll tell you why. Easy transportation and other benefits, and validate the small vehicle concept configuration. And where's the future application and market? If you were to take all the work, good work you put in, move forward. All right, here's recreational personal transport. Vehicle is designed to be small, and that's pretty close to a that kind of market opportunity. Or you could turn into a unmanned aircraft system, carry cargo to use, rescue, deliver the life vest, life raft, and so on. Okay, that's a possibility. Or we can scale it up to 3 to 5 seaters, maybe air taxi and other family sedan, eVTOL sedan. And of course, last one, which is my point, public service. And based on that, I'm going to briefly introduce what NASA, Transformative Vertical Working Group. We have 4 working groups. Now, Group 1 is the private recreational vehicles, short range. Working Group 2 is the commercial intracity, short range. And Group 3 is commercial intracity, longer range. And the Group 4 is public service. And this is the type of vehicle we're talking about for Working Group 1. There's more familiar than other people about this already. And Work Group 2, basically, we're talking about the air taxi type or many other intercity potential applications. And to do that, in Uber's proposal is you need a network of vertiports in order to be able to, otherwise we're going to land in the city. Of course, if you go to the suburban, you may have other options and possibilities. And Work Group 3 basically is commercial intercity. Some are horizontal conventional takeoff, some are vertical takeoff, and so on. Pretty interesting. And Work Group 4 is public services, which covers actually Work 1, 2, and 3. But we focus on what can we do to put on to use for public services. And the mission element is we cover search rescue, law enforcement, firefighting, medical transport, emergency humanitarian response, and military operations. And there's some pretty aggressive targets that we're going to push it, see whether we can make that happen. And And this is the current team. You can see that we have people from all different organizations and different background, different specialties, from universities, companies, industry, SAE, other, and us, of course. And we got, as of today, we got 57 team members. And search and rescue, I'm not going through the details. If you can speed reading, please do so. But just try to get you the picture probably speaks volume about all different kinds of what is the environment, what's the operation we can use it for, and what kind of capability we need to operate. And law enforcement, the world is changing world, sometimes even chaos. But law enforcement do a lot more than just security issues, and there's all kinds of situations to support. So eVTOL can be a huge enhancement in the capability in this area. And firefighting, we all see the big wildfire in California just a few months ago. Huge, way more significant than many years before. But we can do two things. One is we can help the firefighters get in and out and to the right place and quickly put the fire out before it becomes uncontrolled. And of course, we can carry some waters and so on to put our fire early on. Now, even more, if we have a fire changing direction, all of a sudden it heads toward a subdivision. That can be a challenge. How do we get all the people out quickly? Well, if we have a bunch of eVTOL that can normally use for air taxi, we can quickly redirect them over to evacuate civilians. Now there's a challenge to go with that, but I think we can overcome that. How to take a preset air taxi point-to-point operation to a less prepared environment and so on. So the system requirement may be a little bit different. We need to prove out that the vehicle and the system can work safely in a different environment. Of course, the medical transport, that's definitely, if somebody got hurt even on the roadway, transport device that can take the patient quickly to the hospital. And if we can stay within that golden hour, we can save a lot of lives. Of course, emergency humanitarian response, we all know that quite often we lack the last mile capability. We were able to, a lot of times, able to get a supply to the staging area, nearby airports and so on, harbor. We couldn't get to the survivors. And eVTOL is excellent platform to bridge that last mile function requirement. Of course, military has all kinds of possible application for it. We are a lot of times talk to some of the folks in DoD. Two of the very, very interesting applications is eVTOL can do excellent job. One is the resupply mission. The other one is medical evac. And then, of course, there's all kinds of other application potential. As I said, quite often in disaster area, it's challenging to be able to get in and out. The last mile, the roadblocks, earthquake, fire, flood, and eVTOL can make a huge difference. Here's what we came up with as a multi-purpose public service transformative vertical flight vehicle spec. This is a high level, but on the right-hand side is some of the basic features. We like to have modular payload pods, land on water, perhaps optional, and even terrain. You come into a disaster area, you don't necessarily have a nice flat ground for you to land. A compact operating footprint, the transportable to regular roads, got to get them over there, right? If it's a huge airplane that doesn't fold, that can be difficult if people have limited range. Fail-safe critical system, 4G, 5G data link, beyond visual line of sight, vehicle communication, and depends on where we use it for public use, different kind of service requirements and so on. But level 1, level 2, different performance spec requirements. Didn't put on extremely challenging one, but this is the spec capability I think we can achieve today or within a year or two. And of course, we like to have some of the mission-specific eVTOL vehicles here. If you look at the picture, for example, that's a concept that it's for Earthquake. It's a flying machine that can come in and fold the rotor and be able to operate, traversing the debris areas and get to the victims and so on. And that's something that we need to figure out. Depends on whether it's medical transportation, emergency medical care delivery, firefighting transport, water rescue, and other specific missions that we need to tailor the design for that mission to do that mission best. And just as an example, in firefighting, look at it, it's heavy. Okay, we need to have a coordinated command and communication. How do we transport it to the staging area? Heavy smoke, beyond visual line of sight, high temperature. Sometimes the fire can generate very hot air. The turbulence, stability, all challenging. We generate strong wind, deep terrain. How do you land and take off? Fire-induced turbulence, I said that, and the special equipment the firefighter needs to carry with them. And other design considerations, I'm not going to go through the detail. Do we have the floats and so on? But for example, we need to probably fit into a 20-foot cargo container. Then we can transport it not just for deployment, but also ability to transport other places and ship to the worldwide locations. And if it can fit into a C-130, many of our several units into one C-130, that we can get into disaster area. And of course, operational challenges and solutions. Well, we really have a possibility. What happens if we don't have enough mission-specific units, like civilian evacuation? I don't think we can have dozens or hundreds of platforms ready, just everywhere standing by. But we can build it into the current flight operation, commercial business, private ownership, and so on. We can draft it, drafting with clear arrangement, and we'll put them to good use when we need it to. And we can pay according to prearranged usage rate and provide tax and public incentive for participants. So that could be a complementary method to have both specific design tailored public use vehicle and general purpose public use vehicle. And of course, local infrastructure can be a challenge, especially if you're flying to the rural areas and so on. How do you get there? And of course, there are some potential operator. I'm not going to read through the detail. Those are the potential operator for the law enforcement and the search and rescue, National Guards, and so on. That will be with National Park Services and firefighting operations. Office of Wildland Fire, for example, and medical transport, hospital, fire department, EMS, and emergency humanitarian response across FEMA, potentially a big user for this. And of course, military around the world, we have different good use for it. A near-term application, I think the rescue, firefighting, disaster relief will be near-term usable opportunities. And so basically, I'm proposing a distributed, on-demand TVF search and rescue, disaster relief operation network. Basically, so we said earlier, we embed the vehicle and we encourage the OEMs to design the platform that can be used not only for other purposes, but also deployed on emergency. If we have an earthquake, nearby city can. Yeah, there you go. Example of Houston. Harvey flooded big time. Never expected that. But if we have a whole bunch of air taxi, eVTOL, and some personal use, recreational ones, that's capable and suitable for helping people out in the Houston area, we can fly them one stop, perhaps from Austin, San Antonio, even Louisiana, to Houston area, and give it to the theater commander. He has the control of the situation, control the vehicle, control the airspace. He can conduct a safe operation, complementing to the rest of the operation already in place. Of course, there's challenges to design that. Are they going to happen to be the right configuration, functionality, capability? Is the software, the flight software, able to, and the communication system able to fit into the command operations? Can the seat be removed or put on the flat so we can get patients in there? How willing are people going to participate? And range limitation, transportation requirements, and so on. But I think those are challenges we can overcome by design, by specific consideration. And we can do wonders, of course, and communication is the key, of course, but you can see that, Canadian is very, very good at building floats, and of course, there's a couple other companies in the world as well. We can fit a set of floats, normally put in a warehouse, when we need it, put it attached to the flight vehicle. Now we can land in the water because we don't hover too well. eVTOL, generally speaking, don't hover, long endurance. We can land in the water, get people on board and then fly away, so we don't have to hover like a helicopter. So we can complement the different mission modes compared to what the current system we have. And of course, we can expand that to regional logistics and distribution, similar operations, a little further distance. It will be nice to have a hybrid airship with a 47,000-pound payload. In the right-hand upper corner, you can see that that's the C-130, parked there. There's a 310 C-130. I was just here at Tucson last month and went through the boneyard in Tucson. And we have 310 belong to different nations and different organizations parked there. And most of them flyable. And that may be a way to get the regional logistics, putting our eVTOL in the C-130, get to the local regions that we need it. Of course, if we really want to think out of the box, here's a global logistic. If Boeing, and just sponsor here, would reactivate their wind and ground effect concept, can carry 1,400 tons of cargo, go 10,000 miles per mile, and we can fit all that stuff, with fast helicopter, even C-130 perhaps, on the top of it, and get into the theater as a operating base. That's a flying carrier, right? All right, that may take a little while before that happens, but the concept's there. And that's what we can do, within 24-hour response time to get to everybody. All right, moving forward. eVTOL for public service application, providing the last mile of mobility will make a significant differences, even with conservative capability to start with. Now, we need general purpose and mission-specific units and support systems to be effective in various situations. We can really leverage GoFly global effort. This is truly a global effort. And to accelerate the development of practical vehicle and systems. We made a huge progress already. Let's leverage that. Now, only demonstrator and few tests essential for long-term mass deployment. The public service mission can help with positive public opinion and pave the way for wide range use and market. On-demand distributed eVTOL network can further enhance mobility in time of needs. There's a picture on the right, for you, those of you Star Wars fans. Are we talking about fictional reality? Well, personally, I think we're a lot closer to reality than some people may realize. And here's my contact information. If you want to talk more, we have to go through this quickly, but if you want to talk more, please feel free to contact me, and be more than happy to brainstorm. All right. Thank you very much. And
thank you so much, Johnny. Yeah, thank you. Thank you so much for all of that information. We have a number of questions for you. We'll try and squeeze as many as we can in the next 10 minutes or so. First question we had from one of our teams was, like Mulder's Skycar, wing in ground effect is a promising technology that never got off the ground, let alone the sea. Does it have a future?
Well, wing in ground effect machine, I guess you can talk two hands. So one is the like hovercraft. Hovercraft came and gone. We had huge ones, and military is using them. It's a very, very powerful, I think, a public service for search and for large scale rescue operation or over ice will work. But the wing in ground, the terminology we use is the pellet, like the Boeing Pelican, that's flying close formation to the ground, which will significantly reduce the fuel burn. I live in Alabama. We have a bridge. Every time I cross the bridge, I had spent time, which is kind of risky because I'm driving, watching the Pelican flying close to the water. They're very efficient. So for the same amount of power, they can generate. You can carry a lot more payload, or you can go a lot further in range. And in some design such that in case you go off, have an obstacle in front, as shallow island and so on, you can increase the power, hop over it, and come back down. So personally, I think actually I'm aware of there are some renewed activities in wing and ground industry, call it. But I think there are opportunity and technology maybe now with the electric drive, the advanced technology, hybrid power systems and so on. I think they may have a renewed potential, both medium size, well, anywhere from small, medium to huge wing and ground vehicle systems.
Thank you for that. Another question is, and this is something perhaps you can share later, but if you have any resources with respect to design that you might be able to share with our teams perhaps now or when we post the video later.
There's a lot, actually, because even though we are advancing technologies, which is new, a lot of them you can search online and so on, but at the same time, we're designing a flight vehicle. And a lot of good work has been done in the past on that, and it will be wasteful not to leverage some of the good work already done. I can, if folks are asking the question has certain specific, because there's too many of them, certain specific areas, can email me. I'll be happy to share with GoFlow team, and we can put it posted on site, or I can help get a few folks to add to the list.
That would be great. Thank you so much for that. Yeah.
No problem.
You had mentioned certainly use cases that GoFly devices can be used. What are your thoughts on sort of the best first use cases for GoFly? And are there ones that might be easier for early adoption than others?
Yes, I think the first thing, let me put it this way. Absolutely. Firefighting, I think, is one of the potential early adoption. This challenge is, our firefighters, risk their lives, to put out wildfire, a house fire and so on. Be able to get them to the on-site quickly. If it's within the city, of course, we have to worry about the safety and so on. So I think fighting wildfire is the first early adoption because we don't risk hurting people on the ground. But we could get people, especially when there's a dangerous situation. We need to extract firefighters. Fire changes directions all the time. We put firefighters in the mountains and so on in difficult to reach place. and we don't have a good way to get them out. And eVTOL, I think, can get them out of the harm's way quickly and safely. Now, we talk about the massive civilian evacuation. That may take a little time because, that involves a lot of people riding on it and so on. But those special application targeted situation, or for example, hopefully we don't, but somewhere on Earth that we have a heavy earthquake, people got hurt. Cars, helicopter had hard time landing or get to the people and so on. eVTOL might be able to get in, and people already hurt. If you don't get them to the hospital, we may lose them. And in that kind of situation, I think a platform that can get them out of there and get to the hospital medical care quickly is the kind of application, and or deliver. And we can deliver life raft for people in the water. We can basically provide food and water to disaster areas, get them operational, get them proving out the safety and reliability. Then we put people in. I think that may be a good path forward.
So given what you just described for us in terms of perhaps firefighting situations and more specifically in sort of the wildfire situations, who are the customers here? Who are the customers that GoFly teams would reach out to in order to be able to support firefighters in these situations?
Actually, that's one thing that NASA Working Group 4 might be able to serve as a bridge. We were working with different agencies, and we're actually working on a white paper. But so on one hand, we are trying to bridge the OEMs and the potential end customers. Actually, interesting enough, some of the interests came from Air Force. Actually, asked Nathan, one of our members, that why is Air Force could be interested in that? I thought, well, because Air Force manage and operate and coordinate many of the aerial power operations. Of course, California, the forest departments and so on has different contracts sometimes to agencies for the air tanker, for example, for companies that operate that. So you have to basically a different region, different part of the world, the owner may be a little bit different. But we do have, out of our 57 members, some of them has a good knowledge and actually hand-on working relationship. So please feel free to reach out to the Working Group 4. We'll be more than happy to work with you on getting to the potential customers.
Sorry, and I apologize if I missed it, Johnny. What is the best way for the teams to be able to reach out to the working group and connect with folks there? You can basically, you can get online. If you search for NASA Transformative Vertical Flight Working Group, and you can find the website, and or you can just email me and or text me, and I'll give you the link directly. You can get onto it. One good way is to email me. And I will apologize if I take more than a day to respond, but I will respond back to you. Of course. And perhaps we can just connect with you directly and then share that information with all of the teams after your lecture.
Absolutely. And also, just so you bring information, we like to, one of the ways that working group work together is that we have a monthly conference call with our team members. So questions and answers, considerations, things that are common interest, I would tend to schedule into our meeting and to get the participation and involvement from the other team members.
Okay, great. So it could be certainly a good opportunity for GoFly teams to listen in and perhaps post some questions of their own.
Yes.
Perfect. I think we have time perhaps for maybe one more question. What is the most important piece of advice that you might offer to our teams at this particular stage in their design and development?
Well, I would say that try to think of what your move forward direction you want to be. Typically, I would say look for, think of what you really think your market may be. I'm not just totally thinking about commercial. I'm talking about, part of our mission and what we do for is to, do some good. We can save lives. We can do things. But look at where your vehicle or your concept, your technology can best help who in what situation. And that's your application, that's your market. And hope and preferably, as kind of the question earlier on, try to collaborate. Not try to design a platform, say, here it is. And people will say, I'll give you a quick example. When I was a Fairchild, we developed a concept design a project. It's a 35-seat regional jet. We were working with American Airlines and to help configure that airplane because they're one of the best at any customer. And when their team come over to us and we sit down with them and say, oh, this is how we design the airplane, this is how good it is, and so on. And they look at that and say, well, your cargo door is too close to the trading. So, well, it has clearance. So no. Have you seen those guys who drive the loading truck? It's not precise science. Your engineers who think that's enough clearance in real operation, no. And also your connection to clear up your sewer system, you're connecting it to the wrong side of the airplane. I said, okay. Different people have different agencies, different potential operators, have their way of doing things that can be very, very valuable for us to develop platforms that are really useful, really maximize the usefulness and meet the user's needs and the safety, how they operate, and so on. So I would say, think of how your technology best fits certain application, and then get involved, get the end user involved in your design.
A really, really great piece of advice. Thank you so much, Johnny. And I'll pass it back to Gwen for a few final thoughts.
Okay.
Johnny, thank you so much for an incredibly informative master lecture. You provided a lot of useful information on not only what happens during GoFly and development during GoFly, but equally as important, what happens post GoFly in terms of best use cases and first market opportunities. And that's something that all of our GoFly teams need. So thank you very, very much for your master lecture. And to all of our GoFly teams, we look forward to seeing you for our continued master lecture series. We wish you all the best and good luck, and be safe when designing and prototyping and building your flying devices. Thanks so much, everybody.
Thank you.
Thank you.